Not long ago I was talking with a friend of mine about picking up one of those small ready-made tabletop routers that you see on eBay for next to nothing. The 3020s, the 6040s. Anyway, at the time I was fully aware that they'd likely be a letdown. But you know, the price was right and I really just wanted something to screw around with, cutting the old scrap of wood or plastic. I mean, honestly, I didn't think I had the energy in me to see a router build through. And I want to take this opportunity to thank him publicly for helping me dodge that bullet. I mean, no offense to the import routers. I'm sure they do what they're designed to do, and they're probably a heck of a lot of fun. So like I said, we got to talking, and one thing led to another. You know, how much might it cost in raw materials compared to buying something outright, etc., etc., etc. And well, here I am. So the other big carrot to building a semi-decent router, and again, no offense, and some of you are probably already aware of this, but not too long ago, Autodesk decided to give Fusion 360 away for free. Now that's a full-featured CAM package worth, I don't know, at least 4 or 5 figures, giving it away for free. Well, free to hobbyists or enthusiasts or whatever they like to call them. I mean, that's like Autodesk cutting me a big check to build a router, right? Yeah, the wife didn't quite see it that way either. Now, I'm no expert on router design, and there's already a ton of great information online about building routers. And quite frankly, there just wouldn't be the time in a video like this to go through it all. So what I'll do, if you'll have me, is keep you guys along for the company, maybe talk about some higher level build considerations, some of the trade-offs you're likely to run into, some of the trade-offs I made, maybe some tips specific to all welded machine construction, which this is going to be. I just want to get these heads down so I can get the trucks on, but still have some adjustment in here. Biggest thing I'm afraid of is getting this whole thing properly flat, square, and parallel and perpendicular with all the welds that are going to be between these trucks on the Z-axis and everything that's happening on the table side on the Y-axis. So I'm doing the first fit up. This is the Z-plate, the spacer blocks, and the adapter plate. I'm making those names up as I go along, so they might change. Now, as I was designing this, I did paint myself into a bit of a corner. What I was trying to do is get my spindle, so this will go on top of this plate. This is the Z-axis, which will actually move up and down. There are trucks that get bolted here, of course. And then there's the spindle clamp, goes on top. I was trying to keep the spindle axis as close to the gantry as possible. So this is X, this will be moving left to right, and this is Z coming sort of towards me. And to keep the deflections down in the structure, I was trying to keep this as close as possible. Now what that meant, or what that means now, is that I'm going to have a hell of a time getting this together because I've got the Z-axis trucks bolting in from the back and the X-axis truck bolting in from the front. So in terms of hardware, nothing fancy here. These are just basically the best deal I could find on eBay. Import stuff. This is TRH15B. Maybe that means something to you. And ball screws. Now I went with 16-inch ball screws everywhere, 15mm rails on the Z-axis, and 20mm rails on the Y and the X. My motors are essentially all the same. Sanyo motors. These are, I think, 5.4 Newton meters, about 750 ounces. All of my axes I plan to connect with a timing belt. I think these are 10mm. And I did this mostly to shrink the footprint of the machine. So instead of having motors stick out this way, potentially, which gets me either a tall Z-axis or a wide X-axis, I could sort of fold it down on itself and get sort of that center of gravity a little bit closer. I'd like to mention something now before I completely forget about it, and only because you're likely not to see this step, and I think it's important. once all of the axes are set up the way that I like them, I have left space to come back in and drill, ream, and pin all of my bolted connections. All right, I guess it's time to look at this can of worms. This is what I plan to use for the gantry, or the gantry bridge. It's a C-section, 5.5 inches, 140 millimeters. And just to put this in perspective, I plan to mount the X-rails here, and that's where the Z-axis rides. Obviously this would be up 90 degrees, but I think you get the idea. This zips left and right, Z-axis is coming up and down. Now because of the forces on the C-section during, cutting, milling, this tends to twist and open up, and to counter that and to sort of protect some of the, the screw and the sensors I have in the back, I do plan to cap this. And because I can't drill and tap into this thin web, I have some 1/2 inch square stock I plan to weld onto the inside that I can then screw into. Maybe a screw every 4 inches or so. Now the real problem with this C-section, or with any hot rolled structural section, is that it's not flat. And it's probably not straight. It's probably not anything for that matter. And I knew that was coming. The right way to deal with this is, once this, sort of a gantry, everything is welded and machined, is to have the important surfaces machined. This thing is 4 foot long, and it's outside of what I can do here in my garage. And something just doesn't feel right about sending it out. What it would cost me probably just for this operation seems to defeat the purpose of what I'm trying to do here. Now granted, even if I could machine this, by the time this gets installed and welded into place, even if I were to bolt it into place through the rest of the weldment down to the table, I can't guarantee that that machining would help any further than just getting the rails on the same plane. Nothing to say that I'd keep this, square and to the rest of the machine. I wonder if I can show you how much this is here. I don't know if you see the shadow on both ends. Obviously you can hopefully see that rocking. That's probably 20 thou, 30 thou on both ends. It's a bummer. I'll have to map this out and see how long this is along the whole length. But I bet this is relatively consistent. I'm not going to sweat that just yet. Here's about the position where the rails will be installed. If I were to bolt these down now, the skates would be pointing in essentially 2 opposite directions away from each other. And I think if I bolted the plate on the Z-axis on top, I would probably bind the whole thing or damage the bearings, or both. But they are closer together, so it does minimize some of that bow. Even though it feels like a bit of a step, it's not really continuous. I've got a lot of machining to do to this C-section, and I think I'm going to hold off until all that machining is done and just see exactly how this C-section moves. Worst case scenario, I can just send it out and get the thing machined. My tendency, I think, is either to shim these rails if it changes a lot up and down the width, or leave the C-section the way it is and try to adjust for it on the adapter plate that the Z-axis bolts to. It's a much shorter plate to deal with than the long gantry. I've got all 6 million holes drilled and tapped. You saw me cut the slot out in the center. This slot's to connect the spindle plate to the screw in the back, the nut on the ball screw. And And I've got my 1/2-inch square stock welded in place to have some place to screw the back plate onto. Now, instead of doing this on the mill, I'm just going to mark these out and just do this all by hand. The drilling and the tapping. It's not that critical as long as everything lines up. Just a quick thought, I mean, something to always keep in mind when you're welding is where you're putting all that heat in, where the weld beads are, and how much stress that's going to cause. I mean, the welds are always going to introduce something. As well as I thought I had this clamped down, the welds have pulled these square sections up a little bit higher. So I might have a small gap along the edge. Again, it's not critical here, but just goes to show you how it could come back and bite you. The welds are all on the top. Now the way this C-section and backplate are working, when this C-section's under load, it tends to twist and open. So if I'm bolted across the square section, it's going to keep the welds pretty much always in tension and trying to close, you know, in towards the center. So it's going to try to pull those welds apart. If the loads are the other way, I think you'd have to add some welds on the bottom side. Otherwise, I would have just twisted these square sections just right up out of plane. I've ever drilled and tapped so many holes in my life. Next time I'm going to double stick tape the whole thing. But I'm going to bolt this up. We'll flip it over and try to get the first set of rails lined up. So there's a couple of holes. One didn't get tapped and one didn't get tapped deep enough. Anyway, I've got them all snugged up. I think this will do the job for the next step. So I don't know what you guys are thinking, bolting linear bearings to a C-section. So it's ugly, folks. I was hoping I was a little bit luckier. The truck itself is actually pretty tight. There's only 1/2 thou movement in that needle, probably even less, across this 3 inches or so. But as I sweep this across the rails, anyway, the short story is I'm going to have to find a way to machine this C-section. I'm looking at about a 30 thou deviation. Now granted, some of that is also the angle between the two rails, probably not changing at the same rate. But even if I go through here and check it with my level, I get the same story all the way across. I'm not even going to try to describe the kind of warp and twist this thing has. It goes pretty much in every direction. I was hoping it was maybe 5 thou, 10 thou across, you know, the rolled length of the C-section. That I think I could have shimmed out. But 30, 35 thou it just isn't going to happen. And keep in mind that's 30 thou across just the 3 inches of the rail. By the time this gets down to the end of the cutting tool, I don't know, 18, 20 inches away at full extension, that's what, 6, 7 times that 30 thou? I'm going to start making some calls. so that all happened remarkably fast. First guy I called, a friend of mine with a bigger machine, said get your ass over here with some beer money as fast as you can and try to get it done before he's set up for his next job. Sorry if that video in his shop was a little bit quick. It was a little bit sensitive to being the knucklehead with the camera. Anyway, I'm happy with how it turned out. Certainly a lot better than before, though I really should be more careful about what I ask for. I basically told the guy to throw this on his machine and take 40 thou off the top. That's the 30 thou we measured, plus another 10 I thought I threw in for good measure. What I should have said was just flatten the damn thing. You can see there was some areas still low. And the other side's pretty alright. I think you can see this last bolt hole, there's still some mill scale under here. So that's going to be unsupported rail. Not the end of the world. I can stick a little bit of shim under there, but it quickly picks up. So let me just deburr and stone this top surface. I want to get everything wiped down nice and clean. I'll put the rails back on and we'll see what the indicator thinks about all this trouble we went through. Alright, so this is more like it. Still not perfect, but at least we're in the ballpark. I'll try to sweep this and show you what the indicator is telling me. So that's jumping around a few thou. I'll show you, I'll knock that off the rail. I'm having a little bit of problem at the left end, and I'll show a little inset. I'm still up on some of the not milled section. See if I can show you that pick up over there. It's got a slow climb, 5 thou high. I don't know if you can see that, but I think this is the culprit. There's about a 1/16 of an inch of section not milled that's picking up this corner. But like I say, I think easy fixes, and at this point I feel more comfortable moving on. So I figured now's about a good time to get started in on this frame. I've got all the tubing cut and I cleaned up most of the joints, at least the joints I'm going to have to weld soon. And I'm putting together a couple of these H frames. So it's 1, 2, and 3. These are the two sides of the machine. Now you might notice I haven't taken any of the particular pieces up till now to sort of full completion, because I know everything is going to end up moving on me. So for example, the gantry is not fully completed because I prefer to do it once it's assembled on the frame. If the weldment doesn't turn out great and one of these H frames ends up, I don't know, 1/16 of an inch low on one side, I can still tweak the gantry, that C-section, to make up for that. So it's not really important that any one of these components is, you know, dead on. It's important that when they're all put together, that the rails are square and perpendicular to each other. Now before I weld these up, I just wanted to mark out where I need to clean, and I also want to drill a hole in this sidewall. I plan to fill this whole frame up with some kind of media to keep the vibration down. More than likely sand, given what the alternatives cost. So let's talk about welding for a minute. I'll tell you what I think I know, maybe what to watch out for, and perhaps give you a little bit of insight to what you'll be seeing in probably the sped up footage as I go through this frame. I've got a couple of small pieces here. Let's assume for the sake of argument, you know, these are big long pieces. And I'd like to get a nice square weld there. So welding generates a lot of localized heat. That's the whole point, right? When that weld puddle contracts, it's going to pull at your parts. And usually what that means is you'll end up, instead of with a nice flat joint like this, it'll pick up in usually some weird way. So So if I put a weld bead in this corner, more than likely as it cools, it's going to start to pick the piece up, which is usually fine. I mean, you can overpower it with clamps or a big table if you've got one, or you can just beat it back into position when you weld the other side. The problems tend to crop in when your cuts aren't square. So let's assume, this might be 1 degree off, which would be spectacular for my saw. But let's assume that that's the error that you have. And you want to get this thing square. Obviously you won't fill this gap with weld, but I hope you get the idea. So again, for argument's sake, let's say you go and weld this inside corner. The weld cools and it pulls your part out of square. First thing you'll do is get out your hammer and beat that thing back till all your gaps close. But now what happens is, because this cut isn't square, let's say it's at 91 degrees instead of 90, you've closed this gap, so you can't beat on it anymore to straighten this thing out. You'll have to break your weld to get this thing back up to square. So there are a couple things I like to do to sort of mitigate that. I take just some small TIG wire and use it to create a gap. What that does is two things. Gives me a little bit of gap to get better penetration with my weld. But once that's welded, you remove that spacer, your part is now floating on both ends up above that surface. So if I have to beat it past 90 because I have extra material here, I have a little bit of gap that'll let me do that. Then I can come in and lock in the other side. The idea here is to give yourself some options once that first weld bead is down. Now it's not all bad. I mean, you could take that effect to your advantage. If you're welding something up and you see it moving in the wrong direction, you can sort of think ahead and add a weld bead on the inside of a corner to close that angle up. Add it on the outside to open it. Just be aware of what's going on, how things are going to move, and where they're going to try to go. Just grabbing a line here so I can check my diagonals. It's 102 on the other side and 102 here. Good enough for me. Okay, one down, one more to go. The diagonals still check out, so I'm happy with how this one turned out. I'll make one more, we'll get her upright and on her feet. Yeah, I forgot to add one of the holes. I've also fabricated some feet. I'll be welding those on now before I put the cross members between these two H-frames. Nothing special, just some flat stock. I've got a hole here. I plan to bolt this machine into my concrete floor. That should add quite a bit of, rigidity and vibration reduction, and also give me some way to, help level and pull the machine in the directions that I want. So it's been a really convenient addition to the shop. These little digital levels, protractors, the magnetic bases. When I first picked this up, it seemed a little gimmicky. But man, I've really come to use this thing a lot. So I don't know if you can read that on camera. I've actually got two set up. There's also one in the background, which has got that illuminated blue display. We'll have a closer look at that one a little bit later. I bought that specifically for this project. Well, here it is. I have to admit, it's a lot bigger than I was expecting. Nothing's welded up, it's all clamps. I'm just trying to get a feel for where to locate this in the shop. See if I can show you where the rest of the parts go without killing myself. So now I'm just going to work my way through, square everything up, tack it, bolt it to the ground. Alright, well I think I'm going to call it a day. And probably good a place as any to draw a line in the sand and call this part one. The welds there on the right hand side, where I first started, do show my signature passable look. The ones on the left are starting to get sloppy. Now the gantry is just sitting on the structure, and I've got the Z-plate obviously just clamped in place. Just getting a feel for how this thing's starting to look. Now I plan to box this thing in, put some shields up and guards on all the moving components. So I think it'll look a lot less skeletal when I'm done. So if you're so inclined, stick around for installment 2. We'll build a table for this thing, get all the hardware mounted, and start to take the first baby steps.